Hello viewers, welcome once again to my eMath learning platform. In this video, I'm going to take you through the derivatives of exponential functions. After differentiating very many kinds of functions, we now need to establish and know how we can also differentiate exponential functions. But before we do this, we need to first understand what an exponential function is. Now, an exponential function is actually any function or expression whose power is a variable. For example, we can have, if I have e power x, I can have 3 power x, I can have x power x, I can have x power sine x. These are simple and few examples of exponential functions. But now for this specific video, I'm only going to take you through how to differentiate functions of the form e power f of x. I'm going to take you through functions of this form. Now, if you have a function of that form, if we are given for example y as exponential of f of x, then we need to simply know that for you to get dy dx, you're simply going to differentiate this power, then the derivative you obtained, you multiply by this very expression. So it means we can say then dy dx is equal to f prime of x exponential f of x. So what I've done is simply getting the derivative of the power, which gives us f prime of x, then multiply by the original function, which is e of f of x. Now, this can easily tell us that if we have a simple example, 1, where our y is equal to e power x, for example, then we can conclude that dy dx is equals to, now you first differentiate the x, that would give you 1, and so it will be 1 multiplied by the same function. Therefore, we can conclude that given y is equals to exponential x, then dy dx is equals to e of x again. So this is something very important that we shall apply as we go ahead. So that is where we can begin applying the basics from. Now, what if we had another example? For example, we are given y is equals to exponential 3x. What do you think dy dx will be? Automatically, we can say that dy dx is going to be 3 exponential 3x. It will be 3 exponential 3x. What have I done? I have differentiated the power, then multiply that derivative that I've obtained by the same function. So now that can clearly tell us that the concept of differentiating exponential functions of the form y equals to e of f of x is that you simply differentiate the power, then multiply the derivative you've obtained by the original function you had. That is what you need to know. Now let us look at quite complex examples that will involve a mixture of, for example, algebraic functions with exponential functions, or it can even be trigonometric functions with exponential functions. Okay, so our first simple example says differentiate x squared exponential of x cubed with respect to x. Now, what do we need to know about this? First of all, when you look at this function, it is actually a product of two functions. And because it is a product of two functions, automatically we are going to apply the product rule. Remember, we have talked about product rule quite oftenly. So in this case, we shall apply it directly by beginning to say, of course, let y equal to x squared exponential x cubed. Then automatically we can call this to be u and call the whole of this function to be v. Now that means that if u is x squared, then the u dx is going to be 2x. The u dx will be 2x. Then v is given as exponential of x cubed. This is where we need to be a little bit careful. It means the v dx is going to be, I differentiate x cubed, that will give me 3x squared. Then I multiply by the same function. So that is our dv dx. Then by product rule, the y dx will automatically be v du dx plus u dv dx. Then when you make the substitution, you shall have v as exponential of x cubed. The u dx is 2x. The u dx is 2x plus u, which is x squared. Then the v dx, we had it as 3x squared exponential x cubed. That is what we so far have. Then from here, the only thing you can maybe do is think of pulling out or factorizing out the common factors. For example, I can see x is a common factor. I can also see exponential of exponential x cubed being a common factor into brackets. X is already out, so I remain with 2 plus. Then here we have a 3 from x squared. Remember, we pulled out x, so we remain with x. Then we have another x squared here. So remember, because if you had multiplied, this would be x power 4. Now that you've pulled out x, then it means this now remains as x cubed. Remember, exponential of x cubed is already out. So this would be our most simplified result for this. So when you differentiate that given function, you are expected to come up to this level. Okay, so our question 2 says differentiate exponential x into brackets cos x plus sin x with respect to x. Now in this case, I'm going to handle cos x plus sin x as a combined function, and then handle exponential x as an individual function. So it means I can call this to be u and call the whole of this to be v, or any of them can be u and any of them can be v, since we are going to use the product rule. Now if u is exponential x, automatically we expect the u dx to still be exponential x. Why? Because when you differentiate x, you get 1. That is if you differentiate it with respect to x. And so if it is 1 multiplied by the same function, you still get the same function. Then we have v as cos of x plus sine of x. When we differentiate this, the v dx will now be negative sine x but plus cos x. I hope you remember how to differentiate trigonometric functions from our previous episodes. Now from this point, now that we have the v dx, we can now bring the formula for product rule, which is v du dx plus u dv dx. Next step will be automatic substitution. We already have our v. Our v is already cos of x plus sine of x. The u dx, we already had it as exponential x. Then plus u, our u was exponential x. And the v dx, we got it as negative sine x plus cos x. Plus cos x. That is our dv dx. Then the next step is going to be simplifying, of course. I can see a common factor, which is exponential x. I see it here and here. When I factorize it out, I remain with cos of x plus sine of x. That will be minus. First will be, there is this plus of course, but even when you say plus, there is a minus sine x there, plus cos of x. When you look at that carefully, you realize that sine x can cancel. with minus sign x. So that now we remain with exponential x. But now we remain with cos x plus cos x, which will give us 2 cos x. And the final answer comes to 2 exponential x, then cos of x. Then cos of x. So that becomes our dy dx. So when you differentiate the whole of this function, you come up with something as small as that. Let us move on to question 3 from that point. Okay, so question 3 is quite an interesting one. They have given us y as exponential tan inverse of x, and they want us to show that this expression is true. Now you're going to realize that we have the second derivative here, and we also have the first derivative. So it means we are going to do the differentiation thrice so that we reach up the level of the second derivative. So what we do in this case, you need to first be recalling how to differentiate inverse trigonometrical functions. Remember, this derivative of tan inverse was one of the examples in our previous episodes, and so it means we shall just have to recall that if now our y is equals to tan inverse of x, then dy dx, which is going to be the first derivative, will be obtained by differentiating this power. But when you differentiate the power, you get 1 out of 1 plus x squared. Then of course you multiply by the same function, which is exponential tan inverse of x. Exponential tan inverse of x. I think that has not become very clear. Let me lower it a bit. So we are saying that dy dx is equals to 1 out of 1 plus x squared. All this multiplied by our function which was given as exponential tan inverse of x. Now from this level, we can now begin thinking harder. How? We need to look at the final expression that we have to prove, and you will realize indeed that there is no exponential tan inverse anywhere here. But exponential tan inverse of x was originally y. So it means where there is the whole of this, I will replace it with y. So that I have dy dx equals to 1 out of 1 plus x squared, but all this multiplied by y, simply because the whole of this was given as y at the beginning here. Then to make life easy, I can do the cross multiplication first. I can now say, let me have this come this side, so that I have 1 plus x squared dy dx is equals to y. Then from this level, we can now differentiate for the second time, because we need the second derivative as it is indicated here. So I'm going to differentiate these two functions using the product rule, because we have this function here and we also have dy dx as an independent function. So if this is u and this is v, for example, I'm going to go direct and use the product rule by saying I can maintain 1 plus x squared. Then I differentiate dy dx, but with respect to x. That will automatically give me the 2y by dx squared. Plus, I now maintain dy dx also. I maintain dy dx. Then I differentiate 1 plus x squared with respect to x. That will give me 2x. Then the whole of this is equals to, we have y, which also has to be differentiated with respect to x. And that gives us dy dx. So it means at the end of the day, we shall have 1 plus x squared, second derivative, plus 2x. I'm going to bring the dy dx this side, so that now we have dy dx as a common factor. And if it is a common factor, then it means when you pull it out, it will be 2x minus 1. All this into dy dx. And so the whole of that will be 0. Because I already moved this side, I pulled out the common factor, which was dy dx. I remain with 2x minus 1. And that is exactly what they wanted us to prove. That is what they wanted us to prove. So that is how easy these numbers are. Now from this level, I expect to now give you some trial questions to also try out and see whether you can arrive the answers I will indicate for you in my brackets. Okay, so this is our simple exercise. I've only put for you 4 questions, and each of them has at least the guide, the answer, so you will be sure whether you've passed it or not. And maybe to also remind you, we also have a platform online where we have live lessons. So in case you get challenges with this, always feel free to contact me. You will find my contacts and the email in one of my videos in the YouTube channel. Then maybe we can find ways of also helping you join our online school. Please subscribe, share this video, and let's help innocent Ugandans and other learners outside the world out there to benefit from this. Thank you so much. Bye-bye.